Chapter 1, Exploration, Entering the World of Secondary Science, Notes and Summary from Grade 9, Subject Science, Book Exploration. Science at the secondary stage. In middle school, science encouraged curiosity, observation, asking questions, and performing simple experiments. In secondary school, this journey becomes deeper and more thoughtful. Now, science is not only about knowing facts, but also about understanding how knowledge is built. It includes observation, measurement, use of symbols and equations, making models, testing ideas, and even revising or rejecting them when evidence demands it. Science helps us understand nature, technology, and our place in the world. The chapter also explains the meaning of the textbook design. The magnifying glass represents careful observation. The compass represents direction in exploration, meaning asking the right questions and choosing suitable models. Science uses models to understand complexity. The natural world is very complex, so science often studies it through models. A model is a simplified representation of a real system that keeps only the important details needed for a particular question. Examples from the chapter. In physics, a moving car may be treated as a single point. In chemistry, atoms and molecules are shown as spheres and bonds. In biology, cells are drawn using diagrams that highlight main parts. In earth science, Earth may be represented as a smooth sphere with layers. While making models, scientists make assumptions, ignore unnecessary details, focus on what matters most. For example, while studying a falling object, air resistance may be ignored. While studying the heart, many individual cells may be ignored to understand the heart as one working organ. This is not a mistake. It is done purposely to simplify the problem and make it easier to study. Example of modeling cricket shot. The chapter gives the example of a cricket ball hit for a six. To predict whether the ball will cross the boundary without touching the ground, some details matter and some do not. Important details: mass of the ball, speed of the ball, direction in which it is hit. Less important details for a simple model: brand of the bat, color of the ball, amount of grass on the field, spin of the ball, scene stitching, air resistance in a simple first model. This teaches that a simple model uses only the most useful information first. More details can be added later for greater accuracy. Science uses precise language. In science, many everyday words have special meanings. Words like force, work, cell reaction are used very precisely in science. This helps scientists communicate clearly and avoid confusion. Science also uses specific terms, symbols, units. Examples: mass m, velocity v, force F, electric current I. This common scientific language allows scientists across the world to compare results and build knowledge together. Mathematics is the language of science. Science often uses mathematics to express relationships clearly. The chapter says mathematics in science should not be seen as a hurdle. Instead, it is a language that helps us think clearly. An equation is not just for calculation, it tells us how different quantities are related. For example, distance, time, and velocity help describe motion. Mathematical expressions can describe rates of chemical reactions, population growth, changes in energy in a system. Important point: learning mathematics in science does not mean only memorizing formulas. It means first understanding the situation, then identifying relevant quantities, then using mathematical relationships carefully. Importance of standard units. The chapter gives a real life example of an aircraft fuel error caused by confusion between pounds and kilograms. Because the fuel quantity was miscalculated, the plane ran short of fuel and had to make an emergency landing. This shows why standard units are very important. Standard units are needed because they avoid mistakes, they make scientific communication reliable, They ensure fairness in daily life and trade. The chapter explains that when we buy rice or vegetables, a kilogram should mean the same everywhere. Measurements should be based on agreed international standards, not local practices. Laws, theories, and principles in science. As scientific understanding develops, ideas are organized into forms like laws, theories, and principles. These have special meanings in science. Law. A law describes a regular pattern in nature, often in words or mathematical form. Example, Newton's laws of motion. Theory. A theory explains why patterns occur using evidence collected over time. Example, atomic theory explains how molecules are formed. Next, principle. A principle is a broad idea that helps explain situations. Example, principle of conservation of energy. Very important. In science, a theory does not mean a guess. A scientific theory is based on careful testing and critical examination. It can still be improved if new evidence appears. This openness makes science reliable. Science makes predictions. One of the strongest features of science is its power to make predictions. When laws, theories, and models are well developed, they help us predict what may happen in new situations. Examples given: predicting how far a football will travel, estimating the amount of carbon dioxide produced in a reaction, predicting how breathing changes while running. These predictions are not guesses. They are reasoned expectations based on evidence. If predictions match observations, confidence in the scientific idea increases. If they do not match, scientists recheck their assumptions, models, and measurements. Scientific predictions must be testable. The chapter gives an example where Varsha predicts rain because the clouds look dark. To make such a prediction scientific, Meghna should ask questions based on measurable evidence and past patterns, such as what was the sky like when it rained last time? What is the humidity today? Was humidity above 80% during earlier rain? What is the wind speed and direction? Is temperature dropping? This shows that scientific thinking depends on measurable data, not only on feelings or guesses. Why weather forecasts can fail? Weather forecasts are based on models and measurements, but weather depends on many changing factors such as temperature, pressure, humidity, wind. Very small differences in conditions can grow over time and change the result completely. That is why weather forecasts are usually more reliable for a short time than for many days ahead. Science changes with evidence. The chapter clearly says that even highly successful scientific theories have limits. They may fail under new conditions or when measurements become more precise. This is not a weakness. It is actually a strength of science because science accepts correction through evidence. No scientific theory is final or beyond question. That is how science improves over time. Scientific thinking helps test social media and popular claims. The chapter discusses a common claim that food should not be eaten during an eclipse because it becomes harmful. It explains that such claims should be tested scientifically. Scientific questions to ask: what physical change happens during an eclipse? Does temperature change significantly? Does food spoil just because it is in a shadow? The conclusion is that there is no physical, chemical, or biological mechanism supporting that claim. This teaches students to question viral claims using evidence and logic. Estimation is an important scientific skill. The chapter says that a useful scientific habit is understand the situation, identify the important quantities, make a rough estimate, check whether the answer makes sense. Exact answers are not always necessary at first. Approximate answers help. Build intuition, detect mistakes, gain confidence in reasoning. The chapter gives the example of estimating how much rice would feed a family of four for a month by using calorie needs and rice energy values. The aim is not the perfect answer, but a sensible one. Example of estimation: air breathed in one day The chapter estimates how many liters of air a person breathes in a day. Reasoning used: a person takes about 12 to 15 breaths per minute. There are 1440 minutes in a day, so about 20,000 breaths per day. One breath is estimated to be about 0.5 liter, so total air breathed is about 10,000 liters per day. Then the chapter checks whether the estimate is reasonable by comparing it with balloon filling. This shows how estimation can be cross-checked in another way. Science is interconnected. After grade 10, science is usually divided into branches like physics, chemistry, biology, earth science. But the chapter reminds us that the natural world does not have such boundaries. These divisions are made only to organize knowledge. In real life, most problems need ideas from several branches together. Examples of real life issues needing multiple branches: climate change, developing medicines, sustainable technologies. Science also connects with mathematics, technology, arts, social sciences. Example of interdisciplinary science: mask during COVID-19. The chapter explains that understanding how a mask works requires ideas from many branches: physics, particle motion and electrostatic attraction; chemistry, properties of polymer fibers; biology, size and behavior of viruses; mathematics, airflow and filtration efficiency. This is a strong example of how science branches are connected in real life. Science is a human activity. The chapter ends by saying that science is not just a collection of facts, formulas, and experiments. It is a human activity shaped by curiosity, creativity, collaboration, careful questioning. Science grows when people ask questions, test ideas, share results, learn from mistakes. Even if a student does not continue science after grade 10, scientific thinking remains useful in life because it helps in understanding technology, checking information critically, making sense of the world. The chapter finally invites students to begin their scientific journey with evidence, curiosity, and careful thinking. Important key points for revision: science is about what we know and how we know it. Models simplify complex systems by keeping only important details. Scientific language is precise and uses standard symbols and units. Mathematics helps express scientific relationships clearly. Standard units are necessary to avoid errors and ensure fairness. A law describes a pattern, a theory explains it, a principle is broad guiding idea. Science makes predictions based on evidence, not guesses. Scientific ideas can change when new evidence appears. Estimation is a valuable scientific skill. Different branches of science are deeply interconnected. Science is a human effort driven by curiosity and careful reasoning. Summary of the chapter. Chapter 1, Exploration: Entering the World of Secondary Science, introduces students to the deeper nature of science at the secondary level. It explains that science is not just about facts, but also about observation, measurement, modeling, use of mathematics, testing ideas, and improving explanations through evidence. The chapter shows that scientists use simplified models to study complex systems, rely on precise language and standard units, and make reasoned predictions based on laws, theories, and principles. It also highlights that scientific knowledge is always open to revision when new evidence appears. Students are encouraged to develop skills like estimation, critical thinking, and linking ideas across different branches of science. The chapter concludes by presenting science as a human activity shaped by curiosity, questioning, collaboration, and a desire to understand the world carefully and logically. So friends, we have completed notes and summary of chapter 1, Exploration: Entering the World of Secondary Science. We will do 40 MCQs and extra question answers from this chapter in a separate video. If you like the video, kindly like, hype the video and share it with your friends. Also subscribe to my channel and press the bell icon to receive new video notifications. We will meet in the next video. Thank you for watching.